In this video, you will learn about the molar mass. Okay, so chemistry, as you know, is a quantitative science. So which one weighs more, right? A mole of feathers or a mole of bricks? Okay, so think about that. Well, I hope you done. Yeah, it's not a trick question. There is an answer, and the mole of bricks, right, would weigh more. Because remember, a mole is 6.02 times 10 to the 23rd. So you think of 6.02 times 10 to the 23rd feathers, or 6.02 times 10 to the 23rd bricks. Right? You have the same amount there, but each brick weighs more. Right? Maybe it's often good to relate it back to the dozen. So you can also think in your head, well, that would be 12 feathers versus 12 bricks. Right? So remember the mole is just a count. So which one would weigh more, a mole of zinc or a mole of mercury? Okay, well, you have to know where they are. And here is zinc. Let's just zoom in. There's zinc, right? And that's its relative atomic mass, right? 65.38. And here's mercury, right, at 200.59. So if you had a mole of each, which one weighs more? Well, the mercury does. It has more protons and neutrons per atom. And this is what we call, right, the molar mass. What is the mass of 1 mole of a substance? So the molar mass is the mass of 1 mole, right, of anything, right, eggs, marbles, right, in this case, usually atoms or molecules and compounds. Its mass in grams. So if you had 1 mole of it, how much would it weigh in grams? So remember the definition of the mole. We use carbon 12, right? But carbon 12, right, is just one isotope of carbon. So remember, in any sample of carbon, we'll also have other isotopes. That's why that relative atomic mass is not exactly 12. It's 12.01 because of the heavier isotopes. But if I, weighed out 12.01 grams on a scale, I think it's showing here, that would contain 6.02 times 10 to the 23rd atoms of carbon, which is 1 mole of carbon. So 1 mole of carbon, all I have to do is weigh out its relative atomic mass in grams. Okay, so if I wanted 1 mole of silver, I would weigh out 107.9 grams. And that would give me 6.022 times 10 to the 23rd atoms of silver. Same goes for sulfur. Weigh out 32.06 grams, and I'll have a mole of sulfur, or 6.02 times 10 to the 23rd atoms of sulfur. All right, so that's the molar mass. So for any element, the average atomic mass is the molar mass in grams. For a molecular compound, you're going to have to add it up because it is the sum of the molar masses in that molecular, ionic compound. That is the molar mass of the substance in grams per mole. All right, so let's work this out for calcium chloride. So in calcium chloride, we have 1 calcium. So you would look at the periodic table and you would find its relative atomic mass is 40.08. And we have 1, right? So there's only 1 calcium in calcium chloride, but there are 2 chlorines. So this one we're going to have to multiply by 2. Again, though, find the molar mass on the periodic table. 35.45. Okay. So 1 times 40.08 is 40.08. 2 times 35.45 is 70.90. You add up the sum of the atomic masses of the elements to get 110.98. And that is the molar mass of calcium chloride. That's in grams per mole. And so 1 mole of calcium chloride would weigh 110.98 grams on a balance. Okay, so the molar mass now can be used as a conversion factor, right? This is the conversion factor we'll use when we're trying to get from the mass of a substance or an element, right, to the moles, or if you have the moles and you're trying to get to the mass. Right, so remember that these right here is found, that is the molar mass, right? Even this is just flipped around, that you would find on the periodic table, or you can add it up for compounds. Okay, so it is found on the periodic table. Let's just write a little note there. Right, this is the molar mass. Right, you will find on the, I'll just abbreviate it, periodic table. So let's do a practice. How many moles of sulfur are in 1.28 grams of sulfur found in a sample of chalcopyrite? Okay, so what's given is 1.28 grams of sulfur, and we're trying to get 2 moles of sulfur. So when you are trying to convert from grams to moles, you will use the molar mass. So you will look at your periodic table. Okay, so over here, you would look up sulfur, right? And that is for every 1 mole of sulfur, that is 32.066 grams. And remember that is the molar mass. So that is our conversion factor. Okay, so grams will cancel. Your answer will come out in moles of sulfur. In doing the calculation, 3 significant figures, we have 0.0399 moles of sulfur. Okay, so here's a follow-up question. How many atoms of sulfur are in 1.28 grams of sulfur found in a sample of chalcopyrite? Okay, so let's write down what we have. 1.28 grams of sulfur, and we're trying to get 2 sulfur atoms. Okay, so do we know a conversion that'll get us from grams to number of particles? No, right? But we do know how to go from grams to moles, like we just did here, grams to moles. And then we can go from moles to particles. So let me just show you the next slide, just specifically here. Okay, so if we were given the grams, like in this case, 1.28 grams of sulfur, we would have to first go to moles, right, by using the molar mass, like we just learned, and then we can use Avogadro's number to get to particles. So you're going to have to go to the mole first, and from the mole, right, to the next one. And you'll see in later chapters, we'll learn, the mole will get us to many other places, like the volume of gas. Okay, so we know we're going to be doing this in 2 steps. grams to moles, and then moles to particles. Okay, the first one is just like above. Okay. So going from grams to moles, 1 mole of sulfur is 32.066 grams. And then using dimensional analysis, put moles in the denominator. 1 mole of sulfur is 6.022 times 10 to the 23rd, right, atoms. That's the particle. Okay. Grams of sulfur cancel, moles of sulfur cancel. Our answer will come out in atoms. Okay. So do the math, and this comes out to 2.40 times 10 to the 22nd, right? Atoms, sulfur atoms. Okay. So remember, the mole is, right, the intermediate. So if you don't know where to go, go to the mole. That'll get you to the next one. Okay, let's try another practice problem here. What is the mass in grams of 8.19 times 10 to the 19th molecules of aspartame? There's the formula, found in 1 packet of equal. All right, so let's write what we know. 8.19 times 10 to the 19th molecules of aspartame. I'll just abbreviate that. And what I'm trying to get to is grams of aspartame. Okay, so I have particles and I'm trying to get to grams. So going back here, we'll just erase this. We're going the other way now. So in this case, we know the particles, 8.19 times 10 to the 19th. And I'm trying to find the grams. So I have to go to moles first, and then from moles to mass. And how am I going to do that? Well, first one is, use Avogadro's number to get to moles. And then I need the molar mass, right, of aspartame. So you're going to have to add up. This is a big molecule. So you're going to have to add up 14 carbons, 18 hydrogens, 2 nitrogens, and 5 oxygens. All right, so we know it's going to be 2 steps. And in the end, I want grams. So for 1 mole of aspartame, remember, which is C14H18 N2O5. You got to add that. Okay, so, and then I am going to cross cancel here. Moles of aspartame is 6.022 times 10 to the 23rd molecules. And this comes out to 294.34 grams. Okay, so molecules cancel, moles of aspartame cancel. My answer will come out in grams. And I did not calculate that, so let me plug it in. 8.19 exponent 19 multiplied by its molar mass divided by Avogadro's number. And that turns out to, oops, it's in red. Let's change the color there. That is 0.400 grams of aspartame. Okay.